So hi guys, today we have another problem that is K-Palindrome. Basically, you are given a string and you have to tell that how many characters you can remove to make it palindrome. Basically, you have to tell that if the number of elements that we are removing that should be less than equal to the value of K. Okay. So this is the question. If you carefully see that this string is not a palindrome. To make it palindrome, we have to remove either D or E. So one character removal will be the answer, right? And that is less than equal to the K. So this is the question that they are asking for. And what can be the approach? Basically, if you think about the brute force, that will be you have to generate all the subsequences and remove from here and check if that makes a palindrome or not. And obviously, this condition needs to be satisfied, right? So for generating the subsequences, that will be huge. You will need 2 to the power n time complexity. Obviously, we are going to use equation and take non-take approach. Then it will be huge. So somehow you need to reduce the time complexity. And what can we do? Obviously, dynamic programming. Dynamic programming reduces the time complexity a lot by storing the previous data that we know. So what can we do using dynamic programming? Uh, Observe one thing. Okay, let us move to its corridor. Okay. Observe one thing that this is a string, and if we somehow reverse this string like this, A, B, C, D, B, A, and one thing that we know that if these two strings are equal, then this is the palindrome, right? Here you can clearly see that these two are not equal. So how many strings are equal? That is our point. Means how many characters are equal. Now, like you can see clearly see that this AB is equal, this D is also equal, and take one of them. Like I'm taking D here and taking D here. That is equal. So you can clearly see that either we have to remove C or there is another approach that is I can remove these two or keep these two. Okay. So it is somehow reduced to the question that we know that is longest common substring, right? Somehow we have to generate longest common substring and uh, subtract it into the original length of the string. How? Let us have a dry run. Look, carefully see that. What is the substring of this one? That the longest substring that is we are considering A, considering B. Either we can consider D or this D, and then we can consider this one. And what does substring means? Basically, you have to keep the order same, and you can choose either one or not. But the order is important. Like someone comes and tell that, okay, we have DC here or and CD here. So why we are not taking both of them? What's the order? Order is not same here. So this is the substring, sorry, subsequence that we are looking for. So the longest common subsequence, it is maximum 5. And what is the length? Length is 6. So subtract it and we will get 1. So as we previously saw that if we remove one of them, then we can make this string as a palindrome, right? And we do not need to print which one we have to remove, right? So we don't need to think about the proper element, just we have to tell how many characters we have to remove. So this question is reduced to longest common subsequence. And longest common subsequence is a standard question of DP. And if you already know the longest common subsequence, then leave the video right now and try yourself. Just you have to calculate the longest common subsequence, subtract it by using the length of the string and check if it is less than equal to k or not, then equal to k or not. If it is it satisfies, then you have to return true, otherwise false. So this is the main approach that we are using. And if you do not know what is the longest common subsequence, we will discuss in this video. So I have drawn the tabulation table, or you can use recursion. And basically, in tabulation table, let us discuss what is the meaning of this. Basically, suppose I want to know the longest common subsequence of this position. So this column or this cell says that suppose the one string is this one and another string is this one. Basically, A, B, D and A, B, C. And this cell will represent the longest common subsequence value. So what is the longest common subsequence will be here? Basically, these two are same, these two are also same, but this is not. So the answer will be 2. So for each cell, it will tell the current position LCS that we are calculating. Like for this one, we will calculate uh, this much and this much of string, and the answer will store here. Okay, so this is the meaning of this uh, tabulation table, and now you have to observe something. The smallest problem lies here, and why I am putting these zeros. Basically, you carefully think that if we consider none from two sets, basically these are two sets. Okay, you can think of those two sets. One is this is a set A, and this is a set B. Okay, so I can consider null from one set and uh, another null from one set. Suppose we are not considering any one of them. So what will be the length? Obviously 0, because we are considering a null from here and here also. So the length will be obviously 0 here. So that's why the this only this position the value will be 0. And why these are the zeros? Now let us see this combination. A, B, C, and here is null. From set A, we have ABC, and set B, we have null. Okay, so will it be any sense that if we take null and ABC, then what will be the maximum length? That will be obviously null, right? So that's why we are putting 0 here. And same rule applies here also. Let us remove this thing. Nice. So let us try to fill up these blocks. So how can we? Now observe one thing. This element and this element is same. If these two are same, then it will contribute 1 to our answer. Like if you have A here, A in the first set and A also be the second set, and we are considering these two A's. So what will be the length? That will be 1, right? So what will be our previous answer? We have to add 1 here. So if some elements are same, then we have to check for the previous one and add 1 here. So basically we can clearly see that A and A are same. So you have to check for the previous one. Basically I minus 1, J minus 1 element and add plus 1 here. So the answer will be 1. Okay. So for this one, this is A and B and they are not matching. So the answer, that maximum answer, that will be either lie on here or here. Why? Let us see an example. A, B and here A. So we can clearly see that A and B are not same. So if we remove this one, then the maximum answer will be here. Means if we remove this one, this will not contain any kind of contribution in our answer, right? So you can remove this one, and you can see that the answer is here, the maximum answer. And suppose there is another case like this one, A and AB. So if we remove this A, then the answer will be here. So for this case, we have to remove this one and answer will be here. Like you can see in this example, uh, you can see B and A, they are not same. So the answer that we have, that is here. So basically, when we will get some uh, matching, not matching, so we have to basically take the maximum of this element and this element. So what is the maximum of this element? It is 1. And we have to continue for the every cell and getting the answer. So I am completing this cell, and that will be here 1, because this is are not same. This is also not same. It will be 1, not same. And here you can see these are the same values. So we have to go in this direction and check for this value and increment it. So it will be 1. And for this one, it will be 1 also. And now you can see that both two are same. So where the answer lies, that will be here. And two elements are same, so they are contributing another 1. So we have to add plus 1 here. So the answer will be 2. Okay. And now these two elements are not same. So we have to check for the maximum one and it here. Here also same. Now here the elements are same. So we have to take this one and add another one. That will be 2 also. Here also 2. And now we can see that it will be 1, it will be 2, it will be 2. Now we can clearly see that both two values are same. So we have to add another one from here. So it will be 3, it will be 3, 3. For here it will be 1, 1, 3. Obviously the values are same. It will be how much? 3, 3, 3. So here will be 1. These two are same. So 2. Here also this is are not same. So 3. Obviously the max value will be 3. 3 also 4. And here it will be 4. So here it is 3. It will be, sorry, 1. And it will be 2, 3, 3, 4. And the values are same. So 5. So the answer that will be here means n minus 1 and n minus 1. Basically, not n minus 1, it is n, dp of n and n. So the position that the answer will show, that will be here. So this is the LCS, the length of the LCS, basically longest common subsequence. And we have to subtract it by using the size of the string, that will be here 6 and minus 5. So we have 1. If the value of the k is 1, then we can return true. Otherwise, if this condition will not satisfy, suppose uh, this is the answer, and if this answer is less than equal to k, then we have to return true. Otherwise, we have to return false. So basically, this is the approach. Now let us go and try to code it. And first of all, we have to declare the DP matrix, that will be vector in DP. Initially, all the values will be 0. So what is the size? That is n plus 1. And vector int n plus 1, and what will be the value initially? That is 0. Okay. So for int I is equal to 1, I less than equal to n, I plus plus, or int j is equal to 1. Obviously, we are starting from 1 because in 0 position, all the elements will be 0 and we do not need to bother about it. So will be n and j plus plus. Now, if uh, str I minus 1, because we are adding an extra row and column for storing all the zeros. So we have to reduce the location. That will be basically it is 1, 2, 3, 4, 5, 6, and we have to reduce 1 minus 1, 2 minus 1 to get the previous or the original value of the string. Otherwise, it will be an error. So if both two elements are same, j minus, sorry, n minus j, why n minus 1, why n minus j? Basically, uh, you can clearly see that one of them are reversed. So getting the reverse values, then we have to make this calculation, that is n minus j. Then the reverse value you can get the reverse index. And why n minus j? Because of that, all the values are increased by 1. So we do not use minus 1 here. So for that, I am using n minus j. And if both strings are same, then we have to check for the previous element. That will be, suppose this one, like this, previous element. And that is dp of ij is equal to dp of I minus 1, j minus 1, and plus 1. Because the elements are same, so they are contributing plus 1 into our answer. Else, dp of ij will be maximum of dp of I minus 1 j and dp of I j minus 1. Okay. So, and we have to return if dp of n and n, and we have to subtract it by k. If this is less than equal to, sorry, not k, it will be n. If this is less than equal to k, then we have to return 1 or true. And if it is not satisfying, then we have to return 0 or basically false. So let us try to run the code. So it is matching. Let us try another one. Okay. Look one thing. This is already a palindrome, right? But they are using value of k. K, that is 1. So the answer will be 0 here. But as I have said that 0 is less than equal to k, so we have to return a positive 1 for true, basically. So let us try to submit our code. So it is working fine. And this is the approach to solve this question. And obviously, this is not an easy question if you do not know what is LCS. And yeah, so this is the approach. And the time complexity, that is uh, n into n, because we are taking two for loops to traverse all the DP tabulation, DP table, and the extra space, that is n into n also. And we are satisfying the time complexity as space complexity here. And so this is the approach to solve this question. And thank you for watching. Bye. See you in the next video.